Hi, this is BMIS 270, Chapter 3. It's talking about databases, data centers, and business intelligence. So the first slide that we'll take a look at are database systems. So a database is an organized collection of data, and a database management system is a group of programs that manipulate the database, provide an interface between the database and its users and other applications. So what we see is the organizational database here, and that's just like a big can with all your information in it. So say you have your student information system, financial aid, and HR there at the college. You're a student on financial aid, and then you do work study to get that financial aid. So all of that information is included in that database. The hourly rate, the award amounts, your registration is all included in that database. And then the database management system is kind of that interface, that program that you'll go through in order to be able to make these programs run. So we have enrollment programs. That goes through the DBMS and pulls information out of the can. Class lists goes through the DBMS, pulls information out of the can, and transcripts the same thing. So when you get into Oracle and SQL, the databases program, that Oracle is that database engine in the background, and SQL is that database management system. Now a DBA is an IS professional that directs the activities of that organization's database. Now, hierarchy of data. So this is maybe a no-brainer, maybe not. Without data and the ability to process the data, an organization cannot successfully complete most business activities. So we've talked about the importance of the information system, the importance of technology. This goes to even a lower level, if you will, to the bits and bytes. So a bit, by definition, is a 1 or a 0. That's the smallest amount of information that you can have. Words are made up of bits. 8 bits is made a byte, or is a byte, I should say. And then 32-bit microprocessors process 4 bytes at a time. Okay, 64-bit processors process 8 bytes at a time. So this is how that whole data stuff is built. Now, when it refers to a database, what you're talking about is bits and bytes building characters. Character is the basic building block of information. Character is like an A, B, C, or D. Okay, now a field. So when we're starting to take a look at this database, a field is a name, number, or combination of characters that describes an aspect of a business object or activity. In this case, we have name as the field, birth year as the field. It describes a certain combination or characters that describes a certain aspect of the business. A record is a collection of related data fields. So in this case, we have Burroughs, born in 1875, in Chicago, and so on. Okay, and year died, and so on. Okay, a file or a table is a collection of related records. So when we look at this, we see authors. Okay, if I were to click on books, that's another tab that you can see. That would be a whole additional table of nothing but books. This one is genre, and that would show the very same thing. So it's a set of related records. Now, a database is a collection of interrelated or integrated and related files. So in this case, we have authors, books, and genre. They're all tied together to make a database. Now we take a look at the records and tables also. This is kind of what a database might look like, the information within the database. First you have your fields, okay, and remember what they were. Fields were a name, number, or combination of characters that describes an aspect of the business. Okay, so we have the fields. Now we have, and so SID, S last, okay, S address, course name. So those are all objects basically within that database. Again, characters that describe an aspect of the business. Now, going across, we have records. And a record is a group of related fields. Well, a table is a group of related fields. A record, remember, is a collection of related data fields. Okay, I stand corrected. So when I was looking at this, I was looking clear across. And we would ordinarily probably break this apart. But we can go back. It's a group of related fields, and records go across. So we have the student ID number, the student name, the address, the course that that student is taking, the instructor that goes with that course, and then the table is that whole thing, okay, that whole combination of records and fields. Now, a flat file is a simple database program whose records have no interrelationship to one another. Also, you hear flat file referred to as just a plain text file with no special coding within it. A single user, only one person, a single user database is probably what I should say. Only a single person can access a database at a time. Now, access, that's not a great example. Typically, you see it as a single user system. But you can have multiple users. It's not very smart, and so multiple users tend to be a little dangerous with access. Multiple users, this is like Oracle or these big systems, allow dozens or hundreds or thousands of people to access the same database at the same time. So that's a multiple user database. And again, those are the big ones like Oracle. Concurrency controls. A concurrency control is a method of dealing with a situation in which two or more users or applications need to access the same record at the same time. Okay. So what that really means is that if you and I log on and access a third person's information, if I get there first, if I access that information first, I can go ahead and have read, write, and changing permissions. If you look at it second, you're only going to be able to view it until I let it go, until I close out of it. So I can make that change, and then you have to refresh the screen to see that change. Now, if you get to it first, then I have to wait. The idea is, though, that only one person can change data at one given point in time. So that minimizes any accuracy issues. Now, the schema is used to describe the entire database. So it's just what that database looks like. And then SQL, is a programming language designed for managing data in relational database management systems. Okay. Now, the traditional versus database approach. So in the old days, each one of your programs was separate. HR would be separate, financial aid would be separate. The student information system, the course records would be separate. Okay, so it'd be a completely separate program, completely separate database. You would have separate authentication, usernames and passwords to get into this database, as you would with this. So you can imagine if you had access to all the databases, you would probably have maybe a dozen usernames and passwords scattered out throughout. Also, you have to put the first name, last name, address into this particular program for your HR package. For your student records, you have to have, because you have your transcript, you would have your transcripts mailed to you, you would have to put in your address and name separately in this one as well, and for financial aid separately in that one. So if I had somebody entering information into this particular database, will all three people enter the information the same every time for every user? So the odds are no, which leads to inconsistency issues and redundancy issues. Redundancy meaning that same information is in more than one place, and consistency meaning that this address may be different from this one because they are separate pieces of information. Okay, so we kind of see what that looks like here. Okay, the next slide will be the database approach. What does this look like? So again, we have one big can, just like we did in one of the previous pictures. You have your payroll data, you have your inventory, you have invoicing, you have all the data in here. You have your BMIS program, and then all of these separate programs access the information within your database. So all the data is in one big can. Applications simply access certain combinations of the data. Your address is in one spot, and only one spot. When your address changes, you go in and change it, and only you go in and change it. Now that may not always be true with some, you may have HR actually changing that, but one person changes that information. So that's the big advantage of the database approach. Also security, as far as security goes, there's one point of access, and so there's a username and password that goes with that. You may be tied in through a network with some additional security, and within your CAN, within the database management system and within the data itself, there'll be security levels, so that some people will have read, write, and create access to everything, while like a DBA would have godlike privileges, whereas most of us would have really only query privileges where we can look at the data. Now, selecting the DBMS, so there's some issues here. Important characteristics of a DBMS or database to consider: the database size. If you have a little business, just a mom and pop shop, probably Access is just fine. That's the project that you'll use, or that's the software that you'll use for your project. The database cost, again, if you're a mom and pop shop, you want something that'll be as least expensive as possible, maybe even free. Now, going back to database size, if you're a large organization, you certainly want to have a very large, you want that database to be scalable, in that it can run the same with 100 users as it can with 1,000 or 10,000, because your goal is to grow the business. So you want that database to be able to scale up. Cost, now when you get into those databases that scale up, cost becomes a big issue. It increases a lot. Concurrent users, how many users can you get onto that database at one point in time? Think about when we have the registration time, and you have about a 1 week, 2 week period to go ahead and get registered for classes. How many other students are doing that at the same time? Now think about U of M, for instance, Missoula or MSU with 10, 12, 14, 15,000 students. They're all accessing that database at one single point in time. Performance with concurrent users is a big deal. Now, vendor. So obviously with these big applications, you get into the vendor, and what happens is you get tied into one vendor. That's where I was going with that. And that vendor may be Oracle or Banner, and it costs you if you don't like it, if you're not satisfied with that particular service, that particular software program, and you don't like it, tough luck for you, because it costs a whole lot of money to change. That doesn't mean that you can't, but it means that they're very expensive, and when you buy into it, you're probably into it for a while. Now, DBAs, they can make big bucks, 60, 80, 100,000, over $100,000. And that's the person that manages the database. Now, on the other hand, think of the responsibility. A huge amount of responsibility with that DBA to make sure everything's running correctly. Think of the DBA for a company like Amazon, who would probably have many DBAs, but if that database goes down for even a few minutes, they've lost quite a lot of money. Okay. Now, what we have here when building a database, let's see. Okay, finally, we have a few minutes here. When building a database in an organization, this should be part one. When building a database, an organization must consider the content, what data should be collected and at what cost, access, what data should be provided to which users and when. That goes back to those controls and privileges and permissions. Okay, the logical structure, how should the data be arranged so that it makes sense to a given user. So kind of the navigational structure of data, the workflow of data, that type of thing. And then a physical organization, where should data be physically located. So when you're developing database applications, these are all issues that need to be considered. Okay, so with that, the next video will go on to part two, and we'll take a look at entity relationship diagrams.